Our next presenter has travelled from Belgium to be here with us today. So I'm delighted to welcome Joesph Fayolle. Joesph is the operations manager for the UK and Ireland for Biolectric. Biolectric are a technology provider with quite a significant number of small-scale AD systems installed right across Europe and indeed in the UK and I think in Northern Ireland as well. So I know Noel and Joesph would have a lot of engagement over the last number of years, and also Joesph was very close to being the successful tenderer as well in some of these projects in terms of the small-scale demonstration project. And hopefully we'll see a bioelectric plant in Ireland soon too. So you're going to present today on the small on-farm biogas systems at both a UK and EU level. So I'll hand over now, Joesph, to you to make your presentation. And thanks again for travelling here to be with us today to present.
Yes, that's indeed quite a long swim to get to here. Thanks, Sean and Noel, for the invitation. So as I said, Joesph, I looked after the UK and Ireland for the company Biolectric. I've been working for a bit more than 2 years now for the company, overseeing these two countries. So I'll jump straight to it. So obviously you're all aware that we're increasingly paying attention on emissions, especially in the farming industry. Ireland being one of the country mostly targeted as well, where areas can be on methane emissions, phosphate, nitrogen, or water usage. We do see at the same time that retailers and cooperatives, these on the dairy industry, have expressed their intention to be climate neutral, most of them by 2050, so on the UK side like Arla or Müller. However, for them, tricky thing is that most of their emissions are based on the farm level, which is the Scope 3 emissions. These emissions are mostly divided into two parts, which is the enteric fermentation, so which is the burps from the cows, and the rest will be either the management of the slurry, as well as the feed production with the usage of fuel on farm. From us, so we tried and we're supporting the farmers with this changing for the past 15 years. What we design is a turnkey CHP and biomethane solution now. We're probably the European leader in this sector for now. The company, as said, is based in Belgium, next to Antwerp, with the production and headquarters. We operate in about 15 countries now, and will be about 70 people spread into these different countries. We're gradually rolling out our solution through Europe. We've reached our 400th running plant last month. We build 2 new installations per week in our production facility. We can ramp up to 7 a week on day shift only. So we're probably the only global company capable of achieving that currently. And you'll see on the right some of my plants, I would say, in the UK. So out of the 400, we'll have 20 in the UK, 6 this year and 8 next year so far, coming down from the south in Cornwall up to the north of Cumbria. What we try as well to give to the farmers is a different range of products depending on their feasibility on usage on farm and feedstock. So the main core product we had for the last 10 years, to say 10-15 years, was a combined heated power unit generating between 11 and 74 kilowatts of electrical output. And these range from 60 to 500 dairy cows. To say that compared to the Irish market, these are based to housed all year round dairy systems producing about 10,000 liters of milk per year per cow. You'll see below each icons the bulk price of the plants from the smallest to the bigger one. And these comes as an individual system. We rolled out this year in the Netherlands, and the first one will be built in 2-3 weeks now, next to north of Amsterdam. of an upgrading system, so converting the biogas into biomethane to be injected into the gas grid. This comes in two different ways, as the CHP as an individual unit, which will be available for farms starting with 300 dairy cows. And if farms are smaller and within a couple kilometers away, we have what we call a cluster system, where each farm will have bit of the system and pipes will add to a centralized upgrading unit to be injected to the gas grid. So for that, we partnered with Host, you'll probably know within the biogas industry, to provide the three-phase membrane separation device, as we'll have the technology for smaller scale capturing the biogas. So you see as well, the cluster enables us to start as farms as small as 60 cows as well, and you see the bulk price, so we enable biomethane system on farm level below €1 million. The system in one page, so all systems are housed within a 20-foot container to standardize the product, CHP and biomethane. Silo change in size depending on the amount of slurry to be used. The membranes unit is called Bright, which is a product from Host, as said, and then all the technology around it is made by ourselves. What we introduce as well for these technology is a concrete silo. So we still use, obviously, a stainless steel silo for the other systems, but we wanted for the biomethane to have a bigger silo. We went to checking if stainless steel was still available or economics, but it was more economical sense to go to concrete. This enables us as well to put a dry matter intake. So as all our systems are designed to run on slurry only, this enables now to put some other, like silage, dry matter, farm waste, or other products. We don't only sell the system, we've got a comprehensive package for the farmer as well, so from the selling up to the maintenance, where all new plants will be sold with a 15 years maintenance contract, guaranteeing at least a technical performance of 90%. So it's a long-term relationship with the farmer and the other parties we will have for the maintenance in different countries. As we need to get the plant up and running to get paid on the maintenance, but also assuring the farmer the plant will be good up and running for the next 15 years. As we say, the plant will have a lifetime of about 20 years. So I was saying earlier, we only use the slurry. Why doing that? So we're mainly doing that because as it's a liquid, we can highly automate the system, make sure it's pumpable. Daily requirement for the farmer will be 10 to 15 minutes a day with a monthly maintenance on the engine. We try as well to maximize the greenhouse gas reduction through, let's say not hourly, but at least 3 to 4 times a day, pumping fresh slurry into the system. We also, I'll call that back later, we call the smart system to try to steer production when you most need on the farm. And also as slurry being considered as a waste, I would say, or just to be sprayed on the land, that creates extra income. And I was saying this morning, diversifying incomes for the farmers. What we've seen as well in Europe, and comparing our system with bigger scale AD, is that obviously you all know that slurry is mostly water, so transporting it is not very efficient. You'll need to get it back into the farm as digestate, as the farmer will need that for crops. You can have some risk of pathogens having multiple feedstock, otherwise you'll have to get a pasteurization unit, increasing the costs. And then also we've seen effects on the planning, but also for bigger scale that, yes, I'd like to be involved, not just directly behind my backyard, but maybe at my neighbors, and then you end up in having a long time to get that up and running. What we've seen as well is that most of the bigger plants will use slurry as a buffer liquid or a transport liquid for the other feedstock. When doing that, you kind of lose 2/3 of the energy potential from the slurry rather than using it on the farm directly. Regarding the smart, so obviously we get now to a technical performance of 97, 98% on the plant on an annual basis. We want to make the plant more intelligent, so we come to the smart. So depending on how the farm set up, depending on the milking system you have, if it's parlor, robots, rotary. We can time when you need the most of the electrics on farm to offset. For example, during the night, if you use less electricity, we can decrease the engine to increase gas buffer so they can run overtime during the day. We see as well in different markets like the Netherlands, you've got dynamic energy prices. So depending on the price coming from the grid, we can change the power output from the engine to maximize the offset of the electrics. If you've got renewables on the farm as well, as we'll see mostly farms having solar or sometimes wind turbine, we can kind of work with them to not produce too much. When, for example, and unfortunately we see that as well everywhere, the grid is at overcapacity. So even if we could produce more from an average farm, we won't because the grid wouldn't allow us to export all the electricity back. We do see our system as, well, a great solution, but not the silver bullet or the only solution on the farm. So we partnered with several companies 5-6 years ago in the Netherlands to look at how we could offer a farmer a true license to operate on the farm. So looking on the CHP, when you take your daily fresh slurry, pumping into the AD, you will produce green electricity and heat, used on the farm, or excess goes back to the grid. Most of the farms now will have a slurry separator, so separating the digestate into a thin and a thick fraction. The thick fraction will contain most of the phosphate. Some farms will use as a green bedding, so on the chemicals for the farms, and works great. Some will use it as a targeted fertilizer. You can go a step ahead. On 10-15 farms now we have in the Netherlands nitrogen stripper. So, and these works kind of nice with the CHP, because for the nitrogen stripping, you're basically separating the nitrogen out of the thin fraction of the digestate, and for that you need to heat up the thin fraction. So we'll use the remaining heat of the AD plant to heat the thin fraction to 80-85 degrees. Nitrogen separates with an acid combine, and at the end you get an ammonium sulfate rich solution, and another one without the nitrogen, but which will contain potassium and other minerals. These, of course, can be used as crop farming, so when you've got NVZ or phosphate issues on withers and others, that can help tremendously to reduce. And the good thing is that because you target your crop farming, you don't get as much as losses, so that goes back into the feed for the cows, and you make your farming more sustainable and circular. What we've seen with studies from Wageningen universities and Ghent through PhDs is with the AD plant we can reduce up to 82% the greenhouse gas reduction with the slurry management. When you couple to a separator, you can reduce by 45% the phosphate in the soil. And when you add a nitrogen stripper, you can also reduce by 65% the nitrogen emissions on the farm. How we calculate that now on our, so in the sales offer we give to the farmer, we give as well an estimate of how much carbon they're going to deduct per year on their farms. So based from the studies from these two universities and in-house calculation, we take a baseline scenario, which is the farm as it is now without the AD, and then we combine this scenario with the bioelectric unit. And we take, for instance, 6 parameters. The first one being the change of the slurry management, which is, as you see, the biggest element in terms of reduction. We also take into account the offset of electricity, heat, and fertilizer. And for example, a fertilizer, one of my farmers in Leeds in England, he did analysis on the digestate, which was not far from Teagask just before, and is saving about 30 euro per acre this year on fertilizer, only by spreading the digestate compared to the slurry. Of course, being a CHP system, the engine will still produce a bit of emissions, so we take into account standard industry leakages on an AD plant, as well as the CO2 produced from the engine and the nitrous oxides. To say as well, we've got some options on the plant, as well as a catalyzer to further, or to reduce the NOx emission. So you see here on a UK-based farm of 130 cows, which will suit a 22 kilowatt electric system, we can reduce by around 200 tons of CO2 equivalent per year with the AD system. I don't know if it's something being talked about as well in Ireland for now, but mainly in Europe and as well UK. There's more and more discussion on inhibitors on the feeding for reducing enteric fermentation. Start of the year, we partnered with DSM, who is the provider of the Bovaer product, which is an inhibitors removing or enabling the creation of methane in the rumen for the burps. And we wanted to see on 5 AD plants we already had in the Netherlands, when adding the Bovaer, if it would affect the AD. To our results, there's nothing changed on the AD, so the slurry has the same quality in terms of energy to be used. And Bovaer or DSM stating that they can reduce 30% of the enteric emissions. So when you couple these two systems, where would be nearly on par in terms of emission, you can nearly reduce by 50% the overall emission on a farm with these two products. So from a farmer level, government level, retailer or corporation level, that's a great numbers to showcase as well if they want to reduce and be carbon neutral by 2050. We've seen as well, I think that's from the US, when you look at renewable natural gas production, the carbon intensity from natural gas coming from dairy is actually net negative compared to other production like diesel or California grid, which is extremely low with a lot of renewables but still emitting. So that's as well reducing the emissions when producing biogas or biomethane. For the UK, we wanted to see as well what was the impact or difference we had compared to other renewables, so mostly wind turbine and solar offered for farmers, without any grants in the calculation, otherwise we can't compete at the moment. So we looked at a slightly bigger average farm in the UK, which is 180 dairy cows, housed all year round, with an electricity usage of 20 kilowatts on average. This for us makes a 33 kilowatt electric, producing about 240,000 kilowatt hour per year. In terms of our annually production, this equals to a 50 kilowatt wind turbine or a 250 kilowatt solar system. And we also added a line with the AD with the heat use to see how it would affect. So when you look at the only investment per overall kilowatt hour produced was slightly more expensive compared to solar and wind. But when you look at the usable electricity on the farm or usage on the farm and the savings in CO2, I would say we're way cheaper. So it will be 2 to 4 times less expensive in investment per usable kilowatt hour on farm. Obviously, the AD will run 24/7 as a base load, compared to wind, who will need wind, and solar will need light or sun. And as well, the production hours will be different. So that enables us to be cheaper. And when you look as well on the savings, per every pound invested, we'll save 4 times more CO2 compared to solar and wind. So for a government perspective, using taxpayer money, that's really important. And also to note, we only use the GWP 100, which is 28 for the CO2 compared to for the methane compared to the CO2. If you look at the GWP 20, which is about 80, we're even cheaper per pound spent to reduce CO2. This is something now that we mostly see with the different governments we're working with, that the methane reduction is the primary driver for this system, and that only the offsets of energy is the driver of the economics. So you see here a couple countries, regions we're working in. Most of them will have subsidy available, as on the investment side, but also on the production side. These will be limited by either only using slurry or by a maximum size, which is on par with what's been said this morning in terms of a small-scale system. Well, you'll see you're not behind schedule. The UK at the moment, there's none. So maybe you could go ahead compared to UK. It's really important. That's for the CHP. In terms of the biomethane production, we went as well with Netherlands. As well, Netherlands has the lowest regulated amount of methane on their gas grid, so about 88%. We can go up to 97.5, or for those who are using the Warburg index, it's about 55 megajoule per cubic meter. and the Netherlands are subsidizing nearly €2 per cubic meter of biomethane produced onto the gas grid. To give a bit in perspective, in the UK, there's already a green gas scheme, but at the moment, the first year is about 70 cents per cubic meter. So we're nearly 3 times the amount subsidized in the Netherlands compared to England, which makes obviously the business case way more viable to work at these scales. To conclude, I think there's a huge potential for the Irish market. We can obviously reduce the carbon footprint at the farm level. We create new revenue streams for the farmers. We also not get rid of the waste management, but increase or enhance the nutrient cycling on the farm, reduce the imports of fertilizer. And that way, we also create energy independence by having their own production on the farm. And when you take a bigger picture level for the country, it makes us more resilient as well on importing gas, electricity, when we've seen a couple of years ago with Ukraine or maybe other wars coming, let's God know, these will have some spikes. I think we all need to remember at the end that these need to benefit the farmers. They are the ones who are putting these on site, and they are the ones who will be using it. So it first needs to be a cost saving. If it's not sustainable, or if it's not economically viable, it will not be sustainable at all. It can enable the farmers to diversify their revenue by producing electricity, heat, biomethane, depending on where they're at, if they're close to the gas mains or if they have a huge electricity usage, maybe the CHP is favorable for that. And then it's also for farmer and government, it needs to be a long-term sustainability project. You don't have to put 180 plants and in 2 years' time they all break down. It needs to be at least 10, 15 years looking ahead. And that will also help the farming community and the farmers to be more resilient on new regulations coming out. So they'll make as well their farm future-proof for the next generation. Thank you very much.
Thanks very much, Joesph, for your presentation.